Hello viewers, welcome to Fusion Mobile Mathematics Clinic. Today I'll be taking a topic called coordinate geometry. Coordinate geometry deals with points and lines in a Cartesian graph or a two-dimensional graph. Now, in a two-dimensional graph, we have the y-axis and the x-axis. If, for instance, we have a point in the graph, to get the location of the point, give, for instance, this point, we locate it to the x-axis, and we find out it to be 3. Then to the y-axis, 4. So give, for instance, the point is point A. So the coordinate of this point is 3, 4. If we have another point on the same graph, a point B, and we locate it to the x-axis, we have it as 7, and to the y-axis, we locate it as 6. So the coordinate of this point B will now be 7, 6. So we have the location of 2 points in the two-dimensional graph. Next, we'll be looking at the midpoint of the line segment. Now, back to our two-dimensional graph. If we have a line in a two-dimensional graph, now the line, we have a point A here and a point B. And we have located the coordinate as x1, y1. x1, y1. And the other point B, x2, y2, y2. Now, we want to look for the midpoint of this line. And the midpoint definitely will be somewhere in the middle. And we represent it a bar x and a bar y as its coordinate. To get the coordinate of this midpoint, we use a formula. We say for the midpoint for bar x will now be the addition of the coordinates of the first point and the coordinate of the second point, which is x1 plus x2 all over 2 to get the coordinate bar x. Then for bar y, we have y1 plus y2 all over what? 2 to get the coordinate of bar y. And this is how we get the midpoint of a line segment. Next, we are looking at distance between 2 points. Take, for instance, we have 2 points A and B. A having a coordinate of x1 and y1, and B having a coordinate of x2 and y2. Now, the length AB, now we will see that this forms a right-angled triangle, which is triangle ABN. In this right-angled triangle, by Pythagoras' theorem, we know that the hypotenuse square is equal to the opposite square plus the adjacent square. Thereby, we have AB square equals to AN square plus BN square. AN is gotten by the difference between x2 and x1. So this gives us x2 minus x1 squared. Then Bn is gotten by the difference between y2 and y1. So we have y2 minus y1 squared. So AB squared is equal to that, and AB is now equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the formula for finding the distance between 2 points. Next, we'll be looking at the gradient of a line. Now, the gradient of a line is the ratio of the vertical axis to the horizontal axis. Take, for instance, we have a line AB in our two-dimensional graph. We have here the y-axis and here the x-axis. Here is the line AB. A to the x-axis is x1, B, x2, y1, and here y2. For the vertical axis, the change is delta y, and for the horizontal axis, the change is delta x. Now, for our gradient, m will be equal to change in y over change in x. Change in y is the same thing as y2 minus y1. And for x, x2 minus x1. Now, sometimes gradient is also called slope. If we have an angle here and we represent it with theta, now by trigonometry, our tan theta is equal to opposite over adjacent. Now for this theta, our opposite will be the delta y and our adjacent will be delta x. So therefore, our tan theta is also equal to y2 minus y1 all over x2 minus x1. So this is how to find the gradient if you are given 2 points. But if you are given an equation of a line and you are asked to find the gradient, this is what you do. Give, for instance, you are given an equation of a line 2x plus 3y equals to 1. To find the gradient of that point, we refer back to the straight line general formula, which is y equals to mx plus c. M here is our gradient, and c is our y-intercept. Now, for us to solve this question and get the gradient, we have to take this equation and make it look like this. That is, make the y have a coefficient of 1. We take 2x to this side. So we now have 3y equal to minus 2x plus 1. But still, y has a coefficient of 3. So we want it to have a coefficient of 1, like this equation. So we have y, we take 3 to this side, and it divides minus 2 all over 3, x plus 1 all over 3. So therefore, our gradient now is minus 2 over 3, and the y-intercept is 1 over 3. So that is how to find the gradient if you are given an equation of a line. Parallelism and perpendicularity of lines. For parallelism, we are looking at two lines that can never meet. For instance, we have a line and another line. You see that both of them can never meet. Then for perpendicularity, we are looking at two lines, but one goes this way, another goes this way, and they make a 90-degree, and we say that those two lines are perpendicular to each other. Now, in our coordinate geometry, when we have